Hi everyone, welcome back to my videos. In this tutorial, I'd like to show you some techniques how to prove quadrilaterals are trapezoids. So we know that a quadrilateral with exactly one pair of parallel sides is a trapezoid. Now we also know that an isosceles trapezoid has congruent non-parallel sides. So if you remember when I did the trapezoid video, I showed that isosceles trapezoids have congruent lower base angles and congruent upper base angles. So let's take a look at what this means when we do problem solving. So we're given that ABCD is a parallelogram. We're given that segment BD is congruent to segment BE. And we're going to prove that ABCE is an isosceles trapezoid. So we start off with what we know. We know that ABCD is a parallelogram. That's a given. We know that segment BD is congruent to segment BE. That's also a given. And we know since ABCD is a parallelogram that side AB and side CD, they're opposite sides, right? So they're going to be parallel. So I'll just say that the lines are actually parallel because I want to extend side CD. So this line here, segment CE is going to be a subset of the line, right? CD, not the segment, but the line. So either way, we know that segment CE is parallel to segment AB because the fact that it's being extended is not going to really matter for the relationship between these two sides. They're going to stay parallel, right? So we know that ABCE is a trapezoid because a quadrilateral with exactly one pair parallel sides is a trapezoid. So in this case, side AB and side CE are going to be the parallel sides, and of course side AC and side BE are not parallel. So we know that angle ACD, so this angle here, is supplementary to angle BDC. And we know that because consecutive angles in a parallelogram are supplementary. So we also know that angle BDE, this angle here, is going to be supplementary to angle BDC over here. Why? Because if you add the measures of these two angles, you get 180 degrees, right? So we know that angles that are supplementary to the same angle are congruent, right? So angle ACD and angle BDE are both supplementary to the same angle BDC. So in other words, they're going to be congruent, right? Angle ACD is congruent to angle BDE. And we know from the fact that segment BD is congruent to segment BE. In a triangle, if sides are congruent, then the angles opposite those congruent sides are going to be congruent. So in other words, angle BDE, this angle here, is going to be congruent to angle BED, this angle over here. So if we look at 8 and 9, well, we see that angle ACD and angle BED are both congruent to the same angle BDE, right? So angles that are congruent to the same angles are going to be congruent to each other. So in other words, angle ACD is going to be congruent to angle BED. So angle ACD is right here, and angle BED is over here. Well, if we look at this trapezoid, right, these are base angles, right? Angle ACE and angle BEC. So since these two base angles are congruent, we've just proven that ABCE is an isosceles trapezoid. Okay, I'm just going to do one more problem on trapezoids. So we're given that segment AD is congruent to segment AE, and we're given that segment BC is parallel to segment DE. And we're going to prove that BCDE is an isosceles trapezoid. So I write down what we know. We know that segment AD is congruent to segment AE, and we know that segment BC is parallel to segment DE. We also know that segment BD is not parallel to segment EC, right? Because these two lines, if you extend these segments, right, you know, they intersect at point A, so they can't be parallel, right? Parallel lines have no intersection point. So, in other words, we know that BCDE is a trapezoid because a quadrilateral with exactly one pair of parallel sides is a trapezoid. So side BC and side DE are going to be parallel, and these two other sides are not parallel. So I abbreviated this here. So we know that since segment BC is parallel to segment DE, we know that angle ABC and angle ADE, these are corresponding angles, right? Because they're both on the same side of the transversal, if we take the transversal to be segment AD, right? And they're on opposite sides of, you know, one's in the interior region and one's in the exterior region, right? Bounded by lines BC and DE. Well, anyway, if these two lines are going to be parallel, then these corresponding angles are going to be congruent, right? So angle ABC is congruent to angle ADE. And then we just do the same kind of reasoning over here. We get angle ACB is congruent to angle AED. So if we move back a few steps, we know that segment AD is congruent to segment AE. So in other words, we know in a triangle, if sides are congruent, then the angles opposite those sides are going to be congruent too, right? So in other words, this angle ADE is going to be congruent to this angle AED. But if we look at these angles here, right, ADE, so this angle, and AED, this angle here, well, these are base angles, so it doesn't matter if we started at A, we could have started at B, right? It's still the same angle. BDE and ADE are the same angles. But anyway, since these two angles are congruent and they're base angles for this trapezoid BCDE, since they're congruent, BCDE is an isosceles trapezoid. So this video was pretty short. I just went over two problems. I don't know how often people actually go over trapezoids, but I thought I would make a video on it anyway. So I hope you enjoyed this video, and I look forward to seeing you during my next tutorials. Alright, have a good night, everyone. Bye.